Let's find the hidden API. Think of TLS fingerprinting like the fingerprint scanner on our phone. So now it's opening the Camoufox opening Google. Using the asynchronous and also parallel processing, we just need to take around 20 seconds to process all the data. Hey everyone, it's Wilson back again. In the past few weeks, I've been sharing about large language model in my LinkedIn. And actually my goal is simple. I want to share what I've learned and also learn together with you guys, especially in exciting areas like rec system and also AI agents. So yeah, let's connect on LinkedIn and build things with AI together. In one of my recent posts, I talk a lot about data because no matter how powerful our AI system is, if we don't have the data, it's like driving a car with no fuel. So by the end of this video, we will cover scrapping ethics, how to find a hidden API, the importance of TLS fingerprinting and header, automate header retrieval using Camoufox, and last but not least, optimization using async and parallel processing. So let's say right now we are working on a project and you need a layer with data. And one of the most common ways is to get it is by scraping. Yes, scraping means extracting data from a website. Now imagine this. You're asked to get all the drug data from an official government website. It's Indonesian government website. It's not super complex, there is no login, but it's not easy either. Why? Because it uses pagination. The data is spread across multiple pages, and it also includes some security measures like TLS, header, and much more. So my question is, how would you approach this? Some might go with tools like Selenium and then Beautiful Soup, Puppeteer, Playwright, or others may also say, let's use AI for this. And maybe some of you are still wondering where to even start, right? So no worries, let's break it down together. And my personal answer is reverse engineering the API. It sounds so technical, right? So now let's try to simplify this. Websites have two parts. Front end, what you see, the buttons in here, and the title in here, the table in here, everything that you see in here. And the second one is backend. It's actually where the real data lives. The server, the database. Here's the thing. The data that you see all in here, the title of this one, is actually comes from a database. And it is delivered to the front end using something called API. You can think of it like a data delivery pipeline. Now, let's talk a bit about front end. The beautiful web in here is actually constructed using code. You might have heard about HTML. For example, we have a title in here. This one is taken from this part. And then, for example, the registration number, this one is taken from here. And then this part, the search button, is taken from here. So all of this is HTML code. What I'm trying to say in here, this structure is very dynamic. Imagine we're not placing the data not in table, but in a card. Each brand has their own card like what we usually see in an e-commerce website. The HTML will be totally different. So now let's brainstorm together. Most of us scrape by automating the browser using Selenium or Playwright. Here's the behind the scene process if you're scraping using automation tools. The first one, Selenium will open this URL. So it will open the page like a human would. And then taking the HTML code behind the scenes and then grabbing specific parts using something like XPath, CSS selector, or tag names like H1, div, and much more. For example, if you want to take this number registrations, then we will take this span tag. That's it. It's a process if you're using automation browser tools. But have you ever thought, how if the website structure is updated? Our scraper will be broken. And this is what I did. This was my biggest mistake. I mean, I create a scraper that makes the hours, but it's broken maybe 1 month or even days. So here are 3 reasons why browser automation tools and HTML parser not the most efficient scraping method. First, it needs background of HTML. We need to select the correct tag names or XPath or CSS selector. This process takes quite a long time, at least for me. Second, it's very prone to error because the structure could change dynamically. We'll spend lots of time to redevelop the scraper every time this changes. And third, always remember that actually, tools like Selenium or Playwright is not originally built for scraping tasks. It's built for trusting purpose. Then why don't we just use AI? I should say AI-based techniques are so cool, but I believe they're not used in production. The biggest reason is cost. Second is over-engineered solution. If there is a better, quicker, and free approach, why do we need AI for this? So now, let's think a better way. If you understand the source, which is the API, why don't we just get the data directly from it? It already returns a clear JSON, so there's no need to worry about the changes in the HTML or the website structure anymore. You just hit the API and get all of the data. Intuitively, this method is more straightforward, right? The process of discovering the hidden API and extracting data from it is called as reverse engineering the API. As usual, all of the necessary code is available in this GitHub repository, so make sure to check it out in the comment section below. After you clone the repos to your local computer, you'll see this. There are lots of files in folder, but the most important part is this main folder and also the scribing notebook. We're going to start with the scribing notebook. I'll explain the step-by-step process, and after we understand it, then we're going to write the complete and optimized scraper in a Python file. So now let's go back to our target website. First, we are going to talk about the edit. The simplest way is by adding robots.txt after the URL. For example, like this. In here, we will see which pages our data will allowed to scrape. As you can see in this website, there is allowed as nothing, which means all the data here is allowed to be scraped. Please note that what I'm sharing here is fully for educational purpose, so please be wise, okay? Second, this is the hardest part. Let's find the hidden API. First, we need to right-click in anywhere, and we choose Inspect. Next, we go to the Network tab, and also filter the fetch one. So here, let's reload the page and see. As we can see in here, there are two requests made. So let's check one by one. In our case, it's pretty simple. It's just two facts. On your case, probably it's more difficult since calling lots of API, which means we need to check it one by one. Now, the question is how to check it. For example, in here, we cannot see anything. So now let's check the second one. Response. And yeah, as you can see, all of the data that available that we can see in this website. So I can conclude that this is the actual hidden API. In some scenario, if you cannot find any API, then try to reload or click anything like the next button or the filter button. Another important part is to go to headers tab. So in here, we can see the request URL. This is the hidden API that we are going to try to hit, and also the request method. In here, it is post. Request method is very important. Most of the time are between post or get. Then if you're talking about post method, most cases they are payload. This is the payload tab. And take a note, for the get method, we rarely have a payload to filter. We normally pass it as a parameter like this one. Now, let's check in this payload tab. There are draw, for example, draw is equals to 1, and then start and also length. So what is interesting is if we try to change to the next page, which is the second page, the payload, the draw is true. Okay. So it's also interesting if we can see in here, if you're trying to increase the limit, for example, we're increasing the limit to 20 and let's read. Let's check the third request. In here, the length is also 20. So I hope based on this demo, we have a better understanding of how API handles data for the front-end request. After retrieving the hidden API, let's try sending a request using Python. Okay, at this point, you might encounter an error. Don't panic, this is quite common. One workaround is to copy and paste the hidden API URL into your browser or Google. For example, like this. However, you may still get an error, and that's unexpected in some cases. I'll explain the reasons shortly. That said, on some websites, this approach will work. If you're able to see the data directly through the API response, then your task is to complete. You can move to step 4 by processing the data using Pydantic. But in this example, we are dealing with a website that implements a relatively high level of security. So next, we're going to talk about TLS fingerprinting. Both the API and the website may use TLS fingerprinting and request headers to verify legitimacy. Think of TLS fingerprinting like the fingerprint scanner on our phone. Access is only granted if the fingerprint exactly matches the one on record. Similarly, in web requests, if our TLS fingerprint doesn't match where the server expects, our request will be rejected. To simulate a TLS fingerprint in Python, there are a few libraries you can use, including curl CFFI, TLS client, and also RNet. And in this tutorial, we're going to use curl CFFI. To apply TLS fingerprinting, you only need to change one line of code, from import request to from curl CFFI import request. And now let's see the response. Even with this change, you might still encounter an error. However, enabling TLS fingerprinting is considered a best practice in many scenarios. It will allow you to get a valid response. If it works, you can move to step 4. In our case, using TLS fingerprinting alone isn't enough. This brings us to the next important part, header. So now the question is, what is a request header? Request headers are additional metadata sent along with the HTTP request to help the server understand who we are, what format we expect in return, and whether we have permission to access certain resources. So now let's get back into the websites and see what kind of headers we actually need in here. So headers can include, for example, the user agent, which identifies the client making the request, and then the XCSRF token, which helps secure user sessions, and much more. The error code that we get before, which is 419, usually indicates a problem related to CSRF token, which protects against unauthorized or forced requests. So the solution here is to use these headers and pass it in a Python file and then try to request it again. To get a header, we can go to this API and then we right click here, click copy and choose copy as curl in the paste. So you can go to curlconfigure.com and try to paste in here. So this is a Python code and we're going to try to copy and paste it into our Python file. So in here, we will use the curl CFFI and then we're also going to try to request this. And yeah, right now, after adding the header, we can get the data, the exactly data that we see in the website. That's it. Up until this point, we clearly understand the importance of TLS fingerprinting and also headers. Now, let's talk a bit about how we process this data before we dive deeper into optimization. My favorite approach is Pydantic. And as you can see before, actually our data from the API is similar with the dictionary. So in practice, we can also parse the data manually. For example, like data and then we add this like product ID. However, using Pydantic is more clean, at least for me. So in here, we just need to import the Pydantic and import the base model and also import optional from typing. We're going to create a class. I name it as grub and I'll also pass the base model here. And inside of this class, we just need to pass some variables that we actually need from the data that we have from the API. In my case, I want to take the product ID, the product name, product for ingredients, and also the manufacturer name. And another reason why I love Pydantic is we can also add validation. For example, we want the product ID is the string, so you can pass str in here. Or maybe the data is float or integer, we can also pass ent in here. And in my case, I also add optional here, which means when the data is not available, then it's okay. I just need to pass it with none. So basically, we just need to create this class and then to extract automatically using Pydantic, we just need like this. So basically, I'm passing this variable into this grub Pydantic model. So let's try. And here we go. With Pydantic, I can also automatically extract the product ID, and product name, product form, ingredients, and much more. So in my opinion, it's very critical, and also the validation is very important. Moreover, if you want to store the data into your database, and maybe in your case, you have a lot of data to be parsed. So in case you don't want to type your Pydantic model manually, you can also use JSON to Pydantic.com. So now let's continue with the topic of optimization. Headers are very important, but the question is, should we handle them manually? What if you want to automate our data pipeline? Actually, the answer is no. We don't have to do it manually because we can automate it, the process of retrieving the headers using Camoufox. If you want to understand deeper about Camoufox, I highly recommend to visit the official website in here. Now, let's talk about how Camoufox works. If you have used Selenium before, I believe you'll find this familiar. Basically, Camoufox automates the browser, in this case using Firefox. For those of you who haven't seen it before, don't worry, I'll walk you through the demo. So in here, now let's try to use this simple Camoufox example. In this example, I want to open Google in here, go to Google, and the next one, I want to navigate to the website that we have, this one. And then the last one, I want to wait for a second. So now let's try and see what happens in here. As you can see in here, there's a pop-up. So yeah, this is a Camoufox and it's trying to open Google. This is the first step. And the next one, it will open the website that you achieved before. Okay, so that's the process of how you're using Camoufox. Next, let's take a look on the config asynchronous file for the scraper. You can check the main in here and then scraper and then select sync in here, and let's break down one by one. So first in here, we are trying to import some of the necessary libraries. Then we are set up logging in here. And the next one, instead of writing everything as separately in a notebook like before, I've created a class called a scraper. So it keeps things more organized. So in here, the constructor initialize using this init. So initialize the scraper with the base URL, this one, and then the API URL, file name, and also length. And in here, there are several variables. For example, headers. So headers is empty dictionary to store the HTTP headers needed for the API request. And in here is the base URL, the main URL of the website being scraped. And then this one is API URL. This is the API, the hidden API. And then in here, there's also the file name, all tracks to save all the data, and then total data and also length. So if you still remember in the payload, there is a length, which means it's the limit. So how many data we want to retrieve in one single request. And the basis one in here is 100. The next one, now instead of talking directly to handle requests, I want jump first to get headers from browser. So I think you're pretty familiar with this. I've already shown to you how to use this in the previous example. But what makes different here is I'm adding here page on request, which means I want to use this handle request. Why? Right now, we are trying to mimicking. And if you remember, previously, after we open the Google, and then we open the website, and then we right click, we do inspect, we go to network, and we are trying to see the request. We want to find the hidden API, and that's what I'm trying to do right now. So now, let's see what happens in the handle request. So in the handle request, I have an if statement. If product detail in request the URL. You might asking me like, why? Why we have this if statement? So if you still remember the hidden API, actually product data is something that is very unique that showing, okay, this is the hidden API. Maybe in my case, it's not that crucial because there's only 2 requests, right? But in your case, maybe there are several requests. So you need to find what actually make the hidden API is unique. So in here, I'm setting or I'm updating the headers variable in here by taking off the headers item from the request. And in here, I also exclude 3 components. The first one is the content length, transfer encoding, and also set cookie. So now let's jump after the handle request. In here, we're going to the base URL, which is the main website. And then we are waiting for the network idle. And also in here, I'm adding some timeout. So instead of directly close the website, I'm adding some timeout to make sure that we're getting the correct header. That's what I'm trying to do in here. Next is the build payload. But as before, instead of directly explaining this, I will jump first to this retrieve data function. So if you still remember in the previous section, instead of just passing the header, we also need the payload, right? We need a payload to filter. For example, we want to receive a what page, and also we want to get how many data in one request, something like that, that we are setting in a payload. And that's when here I'm setting a payload first. So actually, this is the exact same payload that I copy from the website. Next, we are trying to request. So in here, we are passing the API URL, the headers, and also the payload in here. Next, we are processing the drug data. As you can see here, we are using Pydantic. And if you still remember, previously we are using Pydantic to process the data. And here, I separate it into the schema file. So I place it in a different Python file. So make it tidier. And next, we are appending some of the drugs that we retrieve from array data. So instead of just requesting the data and then waiting and see or maybe locking the data, I don't want to do like that. I want to save the data that I retrieve into a CSV file. So that's the reason I create this function. I think it's pretty simple. It's self-explanatory. Yeah, so this is the basic one. And also, if you want to create a function to save to your database, that's also okay. Okay. Now, let's see to the last section of this code. So in here, I'm setting the length is to 100, which means I want to pass this variable into the payload. What I'm trying to do is, in one request, I want to get 100 drug data. That's it. It's pretty simple, right? So in here, I'm initializing first the scraper class, and also I'm passing some of the parameter. For example, the base URL, the API URL, the file name, and also the length. And then I getting the headers from the browser. And in here, I'm collecting all of the data. And finally, I save to a CSV file. Now, I want to show you that the scraper is actually working and we can see the data. So now let's try to run this. We have the header. Now we are processing the data. It takes quite a long time because here using a synchronous process. So I will speed this up. All right. So we're done. The save run, 10,000 data. We're around 90 seconds. So now let's check the data. Nice. So all of the data is available in here. We have lots of data in here, right? So actually, using a reverse engineering API, I've shown to you that this method is actually working. But of course, our synchronous scraper is not optimized, right? Because we need to wait for maybe 90 seconds to finish off the data. So now let's talk how to optimize this. In here, I have an analogy. Imagine you're at a bank and you have 20 people who need to be served. And there are 4 bank tellers. So using the synchronous approach, we can see in the left side. For example, one person served the first one, and then it takes 20 seconds, and the next one takes 7 seconds. Next, continue the third person, and finally continue the fourth person. Then total time taken by the task, we need 45 seconds. So now, instead of just opening one teller in this bank, how if we open 4 teller? Okay, so if we have 4 teller, which means the 4 people in here doesn't need to wait, right? So we can process all of those 4 people in a parallel, which means if you're trying to serve all of these people in a one same time, of course, the total time taken will be lower, which is become a 20 seconds. And this is the difference between synchronous and asynchronous approach. So now you might ask like, okay, what asynchronous approach and parallel processing is a must in a scraping, right? So the primary reason of asynchronous programming offers such a performance advantages in this web scraping scenario lies in the nature of the task, IO bound. So in short, there are 2 types of works. The first one is IO bound in the left side. So IO bound is a task where the majority of the execution time is spent waiting input-output operations to complete. Examples like the network request, for example, you're requesting data from the API, like what we are doing right now, and also connect to the database, right? On the other hand, we have a CPU bound. CPU bound is a task where the majority of the execution time is spent performing computations on the CPU. Examples like complex mathematical calculations, image processing, data compressions. So now, in web scraping, the scraper spends most of its time waiting for the server to respond to its request. During this waiting period, a synchronous program will sit idle. Asynchronous programming, however, allows the program to initiate other I/O operations or perform other tasks while waiting for this response. Since web scraping heavily relies on network requests or an I/O bound operation, the async scraper in here leverages async I/O library to perform multiple requests concurrently, significantly reducing the overall time span waiting and thus speeding up the data retrieval process. So now let's talk about this async scraper. I won't explain all of this because most of the code is same, but I will explain the main logic behind this. For example, the first one is async IO, and then in here we're also using async Camoufox. Now, let's say in one example like this, we have async and also await. This keyword is used to define a coroutine function. A coroutine can be paused and resumed, allowing other code to run in the meantime. And then in here, we also have a await keyword. So this keyword can only be used inside an async function. When await is used before a waitable object, it pauses the execution of the current coroutine until that waitable object completes. During this pause, the even loop can execute other tasks. So now the question is, what is important? These keywords are the foundation of Python's async IO library, enabling non-blocking IO operations. So instead of the entire program halting while waiting for network response, the async function can yield control back of the even loop, which can do and work on other tasks. Another important one is also async as semaphore. So actually, this is used to control the concurrency of the API request. It limits the number of retrieved data coroutines that can be running concurrently. Now, the important question is why we need a semaphore. So actually, asynchronous programming allows for many operations to be initiated concurrently. However, making too many requests at once can overwhelm the target server of the client's resources. So async IO semaphore is very important because it's a mechanism to limit this concurrency, ensure the scraper behaves responsibly. So now, let's try to run this async scraper and see what happens after we are trying to use asynchronous and also parallel processing. So now it's opening the Camoufox, Camoufox opening Google, and right now we are opening the website to take the header, and let's see what happens after this. Okay, so we get the header right now. Now let's see. Instead of one by one, instead of sequentially, so it's processed in batch, and as you can see, it's very, very fast because we don't need to wait it. So as you can see in here, using the asynchronous and also parallel processing, we just need to take around 20 seconds to process all of the data. So it's a huge difference, right? So now let's see the data to make sure that using the asynchronous and also parallel processing, we also can get the correct data. So yeah, this is all of the data in here. As you can see, it's well formatted. So all of the data is very complete. So yeah, that's what I'm trying to share to you. Using the optimized asynchronous scraper, your scraping task becomes easier. Trust me, this API approach doesn't work for every website, but from my experience, just an illustration. Out of 10 clients that I handle, 5 could be done using this reverse engineering API approach. If you know how to do it, you can build a scraper in just hours. So what I'm trying to say is, before jumping into the complex tools like using Selenium or Beautiful Soup or Playwright, we're giving up like, okay, AI will handle this. No, please no. So try this method first. Always try to reverse engineering the API first. So that's it for today. If you have any questions, thought, or comment, please let me know in the comment sections below. Bye bye.